Hello everyone, we're going to be looking at stars for the next few weeks, and in your books that's chapter 19 onwards. So we'll start with 19.1, the objects of the universe, and what we're going to look at today is, well, we'll start off with looking through the whole of the specification so you can see where we're going, and then after that this session we'll be looking at what we mean by different terms, so planets, planetary satellites, comets, solar systems, galaxies and the universe. And then we'll start looking at the formation of a star, so how a star starts with interstellar dust and gas, there's some gravitational collapse, we start getting fusion of hydrogen into helium, and then of course there's radiation and something called gas pressure that you see. And this should be seen very much as a bridging between what you studied at GCSE and then where we're moving to make it more A-level content. So with regards to what you need to know by the end of this section, so we use the word planet quite a lot. We might not use the word planetary satellites, but certainly the word satellite we will use. You will have heard of a comet, I hope. You might know a little bit about it. Solar systems, rather than just our solar system. Galaxies you will have heard of, but we need to be clear on the definition. And of course the universe, a ever so large thing. Afterwards, so as I said a second ago, formation of a star. And in a bit more detail as time goes on, we'll start looking at low mass stars. So at GCSE you'll have heard that as a medium weight star, and then you will have heard of these terms red giant, white dwarf and planetary nebula at GCSE. You'll have also heard of white dwarf, but you won't have heard of something called electron degeneracy pressure and also the Chandrasekhar limit. More massive stars, you would have heard of a red supergiant rather than just a red giant. And you would have heard of neutron star and certainly black hole and maybe supernova. And also we need to look at the characteristics of neutron stars, so there's a clue in the name, and what we mean by a black hole. Something that you won't have heard of is a HR diagram, Hertzsprung-Russell, and what that is a diagram that plots the different stars based on their power or luminosity and their temperature. And there's a pattern that you see. And depending on what stage of the life cycle of a star, that depends on where you exist on the HR diagram. Then later on, we will look at energy levels. Now, if you take chemistry, you will have heard of a little bit about that, and we'll be looking at energy levels that have negative values, and that's just because we have to put energy in to get something out. So it's like, just be aware that we've got some negative energy coming at some point, or that's obviously not negative. It's just something that we can use to explain what is happening. And then this is more of the chemistry, the emission spectral lines, and also using hc over lambda or E equals hf. And then more on spectral lines, and then we use that to identify the different elements of a star. So we know then what's potentially fusing in a star far, far away based on the light that it's giving off. As the course progresses, we'll look at some more spectrum lines, but absorption ones this time, and looking at diffraction gratings, which you've seen with young double slits, but we've got a different equation, and that's one that can cause some confusion because it is different to young double slit. D sine theta equals n lambda, some different letters. We've then got Wien's displacement law, and that links a wavelength to a temperature. Now, something to be clear on is temperature. It needs to be in Kelvin, so we'll have to look at that in a bit more detail when we get there. We've then got Stefan's law, and again luminosity comes back from the HR diagrams, and then we get another constant to look at. But in essence, power is proportional to the size of the star, so there's our surface area, there's our constant, and then temperature to the power of 4 in Kelvin. And we can use the Wien's displacement law and Stefan's law, and then to work out the radius of a star, so how big it is. We'll then move on to cosmology, and you will have heard of light year. you may not have heard of an astronomical unit, the average distance from the Earth to the Sun, and very unlikely to have heard of the parsec. There's this thing called the stellar parallax, quite hard to explain, so it's well worth looking maybe at that well in advance. A number of YouTube videos available. And then based on parsecs and distances and angles, we can have an equation that tells us how far away a star is, give or take. We've then got something called the Cosmological Principle, and then some keywords: homogeneous, isotropic, and the idea that the laws of physics are universal, so whatever happens on Earth we can assume happens everywhere in the universe. You will have heard of Doppler shift at GCSE, so that makes an appearance back again, and then from that we've got an equation, and we can work out how fast sources of light, so stars, are moving relative to the observer, so us on Earth. Hubble's law, we'll use that to work out how old the universe is, and then we'll look at the idea of the universe getting larger, or is it? And then from that we can use Hubble's constant to then relate everything to the Big Bang theory. And then the last little bit for this whole topic, so this is chapters 19 and 20, I should have said, is we've got a rough temperature of the universe, and we can use that to give evidence towards the Big Bang, so that's in kelvins. And then we've got the idea of space-time that we'll look at. I mentioned we can use an equation earlier to work out the age of the universe, and then what's going to happen. So we know roughly maybe what happened from the Big Bang to now, but then what's that going to evolve to later? So we can look at that. Now, we've got dark energy, dark matter to discuss as well. And what I will say is you'll have lots and lots of questions on this topic. Not all will be relevant, but they will spark your curiosity. I won't know all the answers, and there are some people on the Earth that equally won't know all the answers as well. So do feel free to satisfy your curiosity, look on Google, etc. Just use this as a basis to really explore what on earth is going on, and what as scientists we know, and equally what we don't know yet. And then feel free to ask questions equally as we go through the topic as well. So we'll start with the first thing, the idea of what a planet is, what a planetary satellite is, what a comet is, what a solar system, galaxy, and what we mean by the universe. Now, in your book there is a table, and it looks something like this. So it goes through what each of it is and what the description is. And with a lot of this topic, a lot of it really is about reading around the subject. And yes, I can tell you a number of things, but you're really going to get that depth and breadth of knowledge by looking at lots of different definitions, lots of different pictures, lots of different examples around the universe. So please, you will have to do quite a lot of reading by yourself. It is quite an independent topic, so it makes it quite useful to be doing remotely. So what I suggest you do, this is the basis. I could spend time reading out each of the descriptions, but I think you can probably do it yourself. But in your book, this is on chapter 19.1, which I believe is available on Caboodle, and it is a case of writing the definitions out. You will be expected to state a lot of these points, in particular, those that I've just highlighted there, but this could be 1 or 2 marks. What do we mean by a planetary satellite, or what do we mean by a galaxy? So throughout this whole topic, look at numbers. So galaxy, we're talking billions of stars in one galaxy, and then in the universe there'll be a billion galaxies as well. So on here we haven't actually got universe as a box, but again, it's a collection of galaxies. It's what we are. So what I suggest you do for the remainder of the time today is go through each of these definitions, write it out a few times, make some beautiful notes, but then do some research. So, for example, do you know a famous comet? What's the name of our galaxy? If I hide it, you won't be able to see it anymore. What's the name of the nearest galaxy to us? Or whereabouts do we sit in our galaxy? So there are lots of different types of galaxy. So what's our type of galaxy? And then if we look at planetary satellites, well, we know about our moon, but just to satisfy your curiosity, what about Jupiter? And how many moons does it have, and all the other planets in our solar system? And then why is Pluto classed as a dwarf planet now? There's also the question, where is the asteroid belt? And then, why do we think we have an asteroid belt? So I hope that gives you some ideas of what to go away and look at. Any questions, please get back to me, and I will have another session ready for you for Friday. Hope you're all well. Bye-bye.